everyone, and welcome back. This is the usual writing programming language in Rust stream, and I'm continuing today with the C language. So the C programming language is a language aimed at programming language research. It'll consist of a core number of fairly typical language features in C style syntax. And from that, I will be aiming to develop a more domain-specific language called Ash, which is aiming to be an alternative to Bash scripting that keeps ideally the ergonomics of Bash, but adds more friendlier syntax and features like semantics and things like that, so that we're not dealing with some of the trickier nuances of the Bash Bash scripting language. And so, we're about, I would say, just over 90% done of this C language. The programming environment that I'm developing this in as well is a remote server that all of these panes are running in. I use Mosh to connect to the server with a consistent connection. I use tmux to split up the session, particularly into these different windows that you see here. I do the development just in plain old Vim with the NerdTree plugin. I think I installed that using Pathogen. And I use ENTR on the right hand side to rerun the tests whenever either the tests or the source code changes. And finally in the bottom left here, I just have a shell running Bash. So all very bare bones stuff. Over the years, I had less and less effort to customize things and faff around. I really like to just dive straight into things. So it's very bare bones stuff, no IDE, no fish shell or anything like that, but it works fine. I would say that the things that I probably miss most are in the development environment, being able to jump to definitions of things. And there was one other. I'm not too bothered about autocomplete. Like Vim's one is fairly standard. It's not semantic auto-completion, so you're just auto-completing to anything that matches the prefix that you've done, but it works fine. And so today I'm working on the last bit of assignment destructuring. I've implemented the collect annotation for both lists and function call parameters, and now I'll be looking at that for objects. And I'd say there'll be enough time to look at underscore assignment today as well, to essentially drop variables when you're performing a destructuring operation, or function call parameters or anything like that. So with that in mind, let's take a look at collecting object items in a deconstruction. So we'll be wanting to look at bind, and there's probably a bind object call. Yeah, here we go. And so the syntax for this, let's go ahead and update the parser. So we're essentially going to want to do, instead of, so we have a property list. And there's only one way that we can initialize object literals. So that's the same item that's going to be used on the left-hand side of a production and the right-hand side, the left-hand and right-hand side of an assignment statement. However, we're only going to allow collections on the left-hand side but because we use the same rules, at least syntactic rules for the left hand and right hand side, we're not going to implement we're not going to prevent collecting from being used on the left hand side syntactically. We're going to catch that issue during evaluation. And you can only collect using this simplified single item expression in an object declaration. Go ahead and update the AST. Spread is a little, like, I could say the same thing with collect, like is collect. Both of these are basically verbs, and I'm kind of using them as adjectives when I add the is at the start there. Like is can help identify the variable as a Boolean, but it doesn't read so nicely. I'll leave it as collect for the moment anyway. And so we'll add collect here. So the way this is going to work now is as we go through the prop items, if we find that the last prop item is a collect, then we will capture all of the remaining items and put it into that. So we're going to have to do a couple of checks here. First of all, we're going to have to figure out or basically get all the keys that are being used or that are in the object on the right hand side, and basically tick them off one at a time as they get used in the list of prop items. And then any remaining ones, once we get to the collect variable, then we'll want to go through our list of remaining keys and assign all of those to that. Now, another thing we also want to do is make sure that the spread is, the collect is the last item. So I'm going to add some actual runtime errors here to start off with so that I don't forget them. So first of all, there's going to be an error test for an object literal that contains a collect operation. And I'm also going to have one where the collect operation isn't the last item in the destructure, because the destructure is evaluated left to right and the collect needs to be the last item because it's going to collect everything that hasn't been declared up until that point. Cool, so let's go ahead and define keys. So I believe an object is a list of pairs in terms of implementation anyway. Okay, so it's actually a B-tree map. We'll just see if this exists. So we'll have keys, and then every time an item, and we also want to keep track of the index that we're on. And so basically what's going to happen here is every time we have a prop name, we will, and we actually bind to it, we'll remove that from keys. So let's go and check out B-tree map. And keys returns this kind of item. Might have to convert it into something to be able to remove items from it. I think a set would be the most useful in this scenario. And I'll also need to update, I believe, mod to have an error if collect is being used in an area where it shouldn't be, i.e. during evaluation. I wonder why I'm not using new location error there. There's presumably some reason, maybe the fact that a box was being used there, I'm not sure. But anyway, so in this scenario, handled. More spam, I will just do the same workaround as last time, just to shove that out of frame. Okay. So then let's see. We'll go with that so far. So I was saying something about keys and not being able to remove them. So I'll probably need to convert that into a set somehow. Let's see, hash set from iter. Oh, and I have hash set import already. Let's try just doing that. I presume I'll need to add that, but just in case. Okay, thanks very much. Yeah, I've gotten enough grief for my bare bones Vim setup, so I'll take the win. Thank you. So from iter function, not in there. Oh, because I need to import the trait, I guess. And actually, have I bumped the cargo version? I don't think so. So let's go ahead and do that. Do cloned and collect. Taking a bit of time here. Did I edit the... Usually that would happen when I edited the parser. Okay, and so I didn't need to have iter there. I was able to figure it out. Do I have to do it like that when I give the type? Anyway. Let's try that. And then while we're waiting for that to build, I'll add in the last piece, which is if this is a single and if it's collect, then we're going to create a new object of with all the remaining keys and values. And bind that to to the right hand side prop name, so we'll actually still keep that. And then if collect, we're basically changing the value that we assign. Let's try that. And then in the collect, so we have right hand side down here. So that's binding an object pair. And instead, what I want to do is go through each of the prop items. Let me see how the compiler's going. Okay, so lifetime issues, yeah, that should be all right. That's just in terms of making that mutable and that mutable. So let's see, we'll go for key in keys. We will take the new right hand side. So in this case, it should be possible to just do RHS prop name, because this isn't the remaining keys aren't keys that the user has specified. These have been the ones that we've calculated, so we should be able to use a panicking lookup. Now, it doesn't really account for the case of concurrency. I think that's all right for the moment. So we have the right hand side prop name is going to be the new right hand side. And we'll turn that into a bind next at the end. So that's going to be an object. I'll figure out how to, well, like maybe it'll be a B tree. figured that out. New right hand side is just going to take all the items from the right hand side. So I could probably be a little smarter with that. So that could be a, for example, B3 map new, or it would be from, I guess, and we'd have remaining keys map. And that would be, let me think, each item will be the key and the RHS key. We'll also want to have an error in here as well. If I is not equal to LHS len -1, i.e. if it's not the last item in the list on the left hand side, then we'll return a new error as well. And I think I don't check for that for lists, but I think that's because I was able to catch that at parse time. So you actually can't compile, or you can't parse a file that has the collect item earlier in the list, but I don't have that same functionality for objects, so I'm catching it at runtime instead. Or rather, evaluation time. I'm not quite sure what's meant to be happening here. So we have a left hand side which is an expression. Or maybe I have bind next name. When we've already evaluated the name of the item. So what's going on here? Usually when we have a single item, we make sure that the piece on the... Oh, I think I'm mixing up variables around here. Yeah, because I have the left hand side here. This is the expression on the left hand side, but I'm then calling it the right hand side. Yeah, that is definitely a source of confusion. I mean, no wonder I was getting confused there. And similar with raw expression gets turned into, it should be the left hand side prop name. And that should be up here. So we bind an object pair. And where is LHS being used here? And where is the prop name being used? This is confusing me. Okay, do I need my drawing pad? I think. So we have the left hand side, the right hand side, and the right hand side prop name. And that's basically for reuse, so that I can use the same logic for both a single variable definition on the left and a pair. Yeah, I think I'm going to grab my tablet for this. Just a moment. Okay, so just trying to figure out how to sync this Remarkable to the desktop. Now, it used to be the case that I could connect over USB, which is what I'm doing as well, but I found that recently that doesn't seem to be an option. And also, when I go into present with screen share, it's saying waiting for Wi-Fi connection, despite the fact that it seems to be connected to Wi-Fi. Maybe I just need to restart it. That is definitely one of the gripes I've had with the Remarkable tablet, is that the screen share functionality has just been so flaky and so temperamental. I mean, it's been one of these things that's been changed often enough, I think, in different updates. So for a while you could only do screen share over Wi-Fi, and then for a while you could do it over USB, and that was very stable to me anyway. That was the easiest way of doing it. But then they seem to have reverted that, and it doesn't seem possible to do it over USB anymore, which is a little frustrating. The first time that I did try the screen sharing after the update, it worked first time more or less, but since then not so much. Let's try this again. I've just restarted. Present with screen share to stream content. Make sure the desktop app and your paper tablet are connected to Wi-Fi. Yes, that's what I'm doing. Okay, and now I can accept here. Okay, finally. So here we go. And I guess I will do it on half the screen so that I can see what I'm working with here. I mean, doesn't say much for the code when I'm needing to figure it out manually by hand, but at the same time, hopefully, like, it seems like some of the bits have confused the left hand side and right hand side terminology, so I would like to get that resolved. So let's see. We have the left hand side here is an expression. So that could be something like, I don't know, it could be any kind of deconstruction operation on the left hand side. Then we have equal to, and we have the right hand side, and in this scenario, because we're doing bind object pair, yes, it's kind of the second half of the operation, so we're always doing it on an object, and we're looking up the, okay, so this is why it's called the right hand side prop name. And so we're essentially going to be doing that. To retrieve the new right hand side and assign it to the left hand side expression using bind next and bind next. If I go back to my tablet, bind next takes an expression and a, what else does it take? Valref with source. I think it's the same for bind next name. Oh, my desk is a little cluttered. Everything's falling. So go back to here, we have valref with source. And so with that in mind, let's work through this a little bit. So we have if it's a single prop item, we're going to still be on the left hand side, so it's going to be a single expression. So this would be something like A, just on its own without a colon. And so we turn that into both the raw expression and the prop name location. Yeah, and it is the left hand side. And so it's the left hand side prop name, but we're using it to look up the right hand side. So that's where my confusion, at least the initial confusion, came up, because we're saying left hand side prop name, but it should just be prop name. Now, let's see. Yeah, I think we'll just call it prop name now to remove the ambiguity. Well, might make it more ambiguous in a way, but at least the fact that it's being reused on the left hand side, like it's no longer the right hand side one, because it is coming from the left hand side and then being used on the right hand side. So we'll just remove the distinction of left and right hand side for the prop name and binding. And same for this. Okay, so we've that done, and so when we get down here, we have the right hand side and we have the prop name and the prop name location. And will we keep the say bind object property. And so with that in mind, we're now going bind next name. So we had bind object property for when we have this object on the right hand side and we're doing a lookup of that object. But in this case, we are doing what? The right hand side is going to be, it can be anything, so it'll be a valref with source, and the left hand side in this case is going to be the new name. So in that case, yes, it makes sense that we're going to do bind next name with, let's see, the name is going to be the prop name. The new right hand side is going to be our new object. And the bind type is as we've done. And that, so we just need to give it a good context name as well. So bind object collect failed. Whew, that took a bit of figuring out. There is a certain amount of messing around with the types and things here at the moment, but I think I've got it kind of figured out. And I also need to give the right hand side or the name location here too. So that's the prop name location. Okay, so I have the wrong number of arguments here. So okay, so it doesn't take context because it's not evaluating the name. Okay. And I also need to update error with my new error variance. Other new variant, so bind object collect failed. I need to remember to unwrap that too. And line 410, can't make that from an iterator or from that kind of item anyway. Oh, can I do collect maybe? this. Still can't do it that way. B-tree map. What can I construct that from? Okay, so I can construct it from an iterator. So if I did something like that. From iterator KV, although Vec should implement from iterator, shouldn't it? Do I have to? And I'm importing from iterator. Yeah, and I can do a clone there as well. That'll be fine. Okay, whew. That took a while. But I think that's more or less it now. Okay, and so I have the new error tests. I don't have any feature tests just yet, but so we have, this is test X and test Y. So first of all, we have, yeah, that's as expected. So the error in this case is, oh, what was the name of the error variant? Something to do with collect. Object collect outside destruct. And then the last one was object collect. I'll call it not last. Or it was okay the way it was. Cool. And the error message was, let's see, cannot collect object items outside a destructure. Now, maybe not the clearest error message, but should be fine for the moment. I can always tidy the error messages up later easily enough, I think. And then for this one, it is, yeah, only the last item in the destructure can collect. And the issue is with element 4 there, yeah. That's cool. And so then let's add some actual success tests. So add object collect, and I'll put that under the objects per, although no, I'll put it down here. Or yeah, I'll put it with the object stuff. So A, B, C is 3, and we'll go B and rest is equal to X's print B and print rest. Now, is there a possibility of, oh no, I remember the object keys are ordered specifically for the purposes of testing, so that should be okay. We don't have to worry about non-determinism. And so the items that will be added to the rest will be those. And I guess I'll add another test as well for just more items, just to be thorough. Let's try that. Okay, so, oh yeah, that's just forgetting to add semicolons. Such is the pain of flipping between having languages that use semicolons and languages that don't. Even if I wrote the language that uses semicolons. There is just one failed test there, right? Yeah. And so next will be to add the features file, which will basically just be one of the success tests. And I'll have object collect. I'll use the second one. And yeah, like that. Did all of those pass? They did, and there was a Clippy issue, so let's go ahead and resolve that while we're waiting for the newest compile to finish. 367. So I should be able to just do that, I guess, is what it's saying. Oh, I see what it means now. Let's try that. And we want our features file. Okay, and I think that's just about it. Let's kick off that build again, but I think that's more or less everything needed for the commit. Bump to the version, have the feature documentation. Have our new errors, and we have the unwrapping on the wrapping error. Cool. And that's that feature done. So we're getting very close. There's only a handful of features left at this point, so that's collection done, and that's almost everything to do with assignments finished as well, which is nice. So let's go ahead and add support for underscores, which I think, if I recall correctly, in the last implementation is quite straightforward to implement, but then famous last words and all that. But I think it will be in bind next name, and basically if the name is underscore, then we just skip it. Yeah, and I think that's all that is for that implementation. Now we'll also bump the version for this. Let's see. Yeah, that will go into variables, and I'll probably have a couple of tests for that. I don't think there are any new error tests to add for it. Now I could also do is it the Rust thing? And I think it's in Haskell and maybe a couple of languages, where it's any variable that starts with underscore gets dropped. I'll just do it equals underscore for the moment. And so it'll be, let's see, so basically assignment or declaration to underscore. So assigning to underscore before it's declared and declaring underscore twice shouldn't make a difference. And let's see. So we'll have object destruct underscore and list destruct underscore. Well, it doesn't make a whole pile of sense having underscore there, because, or what you could do is something like this, so you can skip B. So then you print C and you print rest, or you print A and you print rest, and rest will then contain C3. And we can have list destructuring. So list destructuring with underscores makes sense without collection. Doesn't make sense with objects, but in a list you can do it both with the collection and without the collection. Okay, let's try. Oh, and I need to rename that. And I will also do, let's see. What's a good way of declaring multiple variables at the same time? I don't think I actually have one. Should give me the same as long as I don't use declaration. Okay, let's see how our test results are doing now that I've been doing all that on the side. Okay, so 2 failures. Which ones are passing? So we have the variables tests and underscore tests. Underscore list destruct underscore 1 and 3 passed. And did object underscore fail, I guess? Variables object destruct underscore. Okay, so it was the assign underscore failed and list destruct underscore 2. So for assign underscore, it was a syntax error. Okay, so that's just, okay, so again, it's all just the semicolons as always. Oh well. There are worse things. I could be stuck on that for a lot longer. And is that all? Okay, that's all the test passing. This is an even simpler feature than I was imagining. Oh, and it's for function parameters as well. let's see there. So, okay, so we have object doesn't contain that property, and up here it's because we didn't declare that. So that's a little bit of extra handling that we need to support. So that's another one where if the prop name zero is equal to underscore, then we just return okay. Does that make sense? Yeah, because otherwise it will try to look it up on the right hand side before trying to do the assignment. Interesting. So that's one case where I might need to figure it out a little bit more. How did that not show up in my other tests? Oh, because, yeah, this doesn't make sense. Yeah. Because I was doing this kind of a thing in the other tests. And yeah, that's another thing that would be worth checking as well, is the use of double underscores. There we go. list destructuring and object destructuring as well. Not exactly the most ergonomic thing there, but it's more nice to have for completion's sake, I think. So despite being one of the smallest features, especially in terms of implementation, nearly have some of the most tests written for it. That's interesting. Okay, that's cool. So we're coming very close to the end now of the C programming language anyway. So next we have implementation of type, essentially type properties or type methods. So I guess I'll keep going for another 30 minutes on the stream. Let's see. Yeah, let's give it a go. So we have built-ins and we have type methods available. So most of it is really just to add the syntax first of all. So we have property access, and so we'll add type property, and that will actually need some Lexer updates too. So we'll call this so most of these have names, at least the double character symbols have names that just reflect characters. So whether I call that dash greater, I could also call it arrow, but I think I'll just keep consistent with the names that are there. dash greater than. So that is AST. So I have prop, whether I add a boolean to that to distinguish it. Because it's basically the same operation, it's just that the effectively property table or method table that is being accessed is different. So instead of accessing an object property, you're accessing, well, the object whose properties you're accessing are essentially the type object. Now, having said that, I won't allow assignments to that, but that'll be easy to catch too. So type prop bool, and so hopefully this won't take too long to compile. But by that stage, yeah, so it's mod and bind. So in the case of bind, it should be fairly straightforward. And it'll be a case of type prop. And if it is a type prop, then we return a new location error, which will say what? Let's see. And so that is, yeah, I don't need a value there. So that's that case covered, and then we just have mod, so we have prop. And yeah, I had a feeling I might need to dereference that, so that's confirmation. That is necessary. And so if it is a type prop, then we evaluate the object, and then so we need to evaluate the object either way, I think. Okay, we'll do like that. And then we'll have another case where if it's a type property, then we'll do a lookup on the type. And it'll be a matter of, let's see, looking up the type methods. And that's all in the evaluation context, which is just the context. So we'll have context, which will contain built-ins, I believe, isn't it? Yeah, built-ins, and then built-ins have type methods. Do I have any of those defined already? No. Oh, maybe. Nah, just... Do I definitely not? I wonder. Or have I just had that there since the start so that... Because I knew I would be needing it later. Because I basically implemented the language before. So we'll have type methods, yeah, even though on the front end I'll be calling them the accessor for type properties. Under the hood, at least to start with, there will just be type methods defined. So they won't be general properties, so there won't be fields, only methods. Well, we'll need to do an evaluation here as well anyway, and then it'll be a matter of matching the type and then doing a lookup based on that. So we would have so say we have string, we would do a lookup. At that point then we have an object again that we can use to progress. This is gonna look very nasty, but let's try this. No, maybe not. Okay, let's just implement it on strings first. that will essentially be this. And that will be the method that we found on it. Let's just try something like that. And a simple one to start off with, I think, is string length. Even though we have print. Okay, so print is the only built-in function we have so far. So what is a good way of creating a B-tree literal? I guess this. So from B-tree from. And we have the key value pairs. And the first of these will be length. And it'll be a new built-in function. And the name will be length. And the definition, how did I define? So I guess I'll go to functions. So we have this. V's. How does that get called? Oh yeah, the list is the list of arguments. So it might be nice to have a helper function that verifies the values and their types, but anyway, for the moment we will say V's length should be 0 and let's see, let V equals if sum V is equal to this, else return an error. And the value that we return will be a new int. So V should be this, and then we'll also want to do so that'll be a valref with source. And then we'll want to do a match on that. That's something that we can simplify as we add more type methods, but for the moment we're just gonna say if it's a string, then we'll do this. Otherwise there'll be an error, and this will be a dev error. And we'll do we'll do the value of the new integer there, and the new integer will be the length of the rendered string. Yeah, and we won't need a return there either. Okay, so a bunch of this implementation is a bit rough and ready, but it's mostly just to get a feel for how this is going to work, and I can shore up the implementation later. Let's see, where is error defined? In eval. whole lot of lifetime issues there. So let's see. Non-exhaustive in where? Oh yeah, because of my type matching. So I'll just add a to-do down there. I'll just say that's the same thing. Main. Oh yeah, it's been a while since I've updated that, but yeah, I need the dash greater than symbol. Valmod 688. Yeah, the actual value never gets used, does it? That's making me wonder around about the correctness of the stuff down here. So in this case, we're looking up the type method that we're supposed to use, and here we get it. So yeah, we have the type method by this point, but then we're using v here, which I'm kind of surprised by. I feel like that should be, for example, down here it should be props, in my opinion. I'm not quite sure how that's actually working otherwise. Have I done that somewhere? Like methods or operations? No, that's kind of maybe functions. Maybe that's not actually working. I wonder. What I'll do is I'll leave that off for the moment and see if I'll add just a test for methods, and I'll just say that that turns into an error. Or I'll just say, okay, value you null. Let's try that. So it returns operations, loops, functions. Go with that. No, I'm fairly sure I have implemented type methods somewhere. Variables combinations. Okay, I think I actually have all the different pieces required for method calls, but I don't think I've actually implemented them. Now, there was one place where it was the function combinations where it was doing greet, and that's the closest thing to an anonymous function or a method at the moment. But let's see. Is that compiling now at least? No, I forgot. So there's type methods left to fix. 46. How do I resolve that again? Oh yeah, that's just this. Okay, it's building again now. So let's go ahead and implement a method here. Do I access it with this? Did I add support for methods? Maybe I didn't. Oh yeah, so I think it's accessed with this. And we can go so let's see, person get age, or let's say that increase age so here we'd be looking for 20 followed by 21. Let's see what happens there. And that's not getting picked up by ENTR because it's a new file, so we'll restart the loop again. Properties can only be accessed on objects. Got function. So line 13. Well, it's this one. What does that even mean? Properties can only be accessed on objects. Oh, it's saying that person is a function. So line 13, column 7. And it's saying eval return expression failed. Not a lot. Doesn't instill a huge amount of confidence in the error messages at the moment, but at the same time I know those are things that can be changed relatively easily. I'm happy with the amount of test coverage there is at the moment. So with that in mind, only be accessed. So property access on a non-object, and the object is a function. How does it figure that? Let's break this down. Okay, we'll start off with person, and I'll also just check methods. So we're just running that one test. Yeah, so that's definitely an object. And in fact, might be nice to have a function as well that gives us the type. And again, this is just a temporary thing. So I'm not going to put too much effort into it at the moment. Again, just getting the implementation functional, and then we'll worry about getting it more presentable. Kiss, your nose is so cold and wet. So let's see, we'll go to main. I think that's where, yeah, these are added to the binding. do to vec. New stir from string. Let's try that. Oh, the CPU. Oh, okay, no, it was just running on high a bit. Okay, so that variable is most certainly an object. I'll just print a new line there to get some space in the rendering. Unexpected, oh yeah, because the language only has support for quotation marks, not apostrophes for strings anyway at the moment. Okay, so it's still an object. And if we say type of person dot age, what happens to us then? Okay, so that is a function. And if we then try to call it, what happens? Is the right hand side being is it doing a right binding? So we've gotten to line, let's see, we've gotten to line 19. And it's saying properties can only be accessed on objects, but got a function. That to me indicates that the left hand side is a function. So this dot is happening here. Yeah, so I'll need a bit of debugging on that. That's not going to be something I will finish today though, even though I am kind of curious. So let's see, access on non-object. And so what have we got here? So we're outputting the value, which is the thing on the left hand side. We have the name on the right hand side. So strange. I'm wondering, can I print the value? So it's render type, we have that. Let's try this. Okay, so lots of work in progress code at the moment. But yeah, I'm taking a bit of a break from implementing the new type methods to focus on actually verifying that regular methods work as expected. And I mean, they're not. So I'm interested in getting to the bottom of that. Okay, so this is a function. Can I get the name of the function? So if I have a value in general, yeah, it will have a name. Yeah, both built-in functions and regular functions have names. Debugging symbol for that. And that's something that's, I think, nice to have in general, so I will port that over to the original built-in function print as well. If I even had an insight into what exactly is going wrong, just to satisfy my own curiosity, then I could leave it for today. But until I get that, that's just too... Okay, so it's an anonymous function. Yeah, which the both of those are. What is the AST looking like at this point in time? I wonder. Now, I might be biting off more than I can chew with printing the AST here, but I think it's something that could give me a bit of insight into what's going wrong. Oh, that's about what I was expecting in terms of the AST at least. Whew. Okay, so I think we'll go ahead and copy that and do some kind of rendering. Let's see what's my best approach here. So if I go, well, first of all, copy it over from the buffer, put it all onto one line, I think, and then if I go ahead and say that opening braces will be replaced by a new line and an opening brace. Then that. Does that. And then if I do the same with closing brace, although I'd like for it to add some indentation to make things a bit easier to comprehend. I think there might be a pretty print function on Rust debug. Yeah, so with the pound symbol. Okay, that definitely makes things a whole lot simpler in a way. So let's see. The area that I'm most interested in is, I think, towards the bottom where we're doing the print of the type. So this is all on line 18. Yeah, that's where the error is happening, isn't it? Line 18, yeah, exactly. So we'll go to line 18. We have print, the arguments to print is just, there's one, it's in the first list item, it's an expression, it's a call. And let me put that on the right hand side so I can work through this on the left hand side. So we have a call of what? There's a function var name type, and then the args to that are just 1, which is another expression, and it's a call on a function let's see if I open up the file itself as well. Where was it? Methods, I think. And this is the line. In fact, if I simplify that and just say person age like that, and then I redo the file, and that will be on line 13. Okay, and that's going to be a call on a function, and the function itself is a prop, and we have args, we have no arguments, and we have the function is a property and the expression is a variable person. So what it's saying is that this is a function call on a property lookup of a variable person, and age is being performed on the property lookup. And that's exactly what I would expect. Like, that's the exact AST that I'm expecting in that scenario. So what is this sequence of execution that's running, that's resulting in a function being accessed as a property, or that's having its properties being accessed? And it's also val return expression failed. That is also possibly something that I can do. Is disable error unwrapping. And that should give me essentially a different kind of call stack. Which again is another just view of the sequence of errors. Okay, yeah, so that might actually be a little more helpful, and is one of the reasons why I've designed it that way. I can actually, as opposed to getting the stack trace from the runtime of what functions were called on the runtime. I will get a stack trace of the interpreter itself. What were the sequence of what it was the sequence of calls that were in progress when the error got raised. So eval return expression failed. Yeah, it was saying that, but there is no. Oh. This is, yeah, I think. So the error was being thrown. I was getting thrown off by the stack trace, I think. Because I thought this was causing the error, but actually it was this seems to be causing the error. Because this, as far as I can tell, isn't being set properly as the source object. New val, no, what was it? Prop. So, like it's V there, but I think that if I take a look at the old version of the code and I go to expression prop and I look up an item, that's for assignment. This is for prototypes, and I might actually look up the implementation of that as well. That's doing vclone as well. How is that working? So at this point in time, this is referring to this. Yeah. Which is a function right now, but I wanted to refer to this, which is the dude up here. The item that actually gets evaluated. Object props. Maybe that was just a bug on the old implementation as well. I'm not really sure how any of the code that I was doing with regards to methods, maybe I wasn't using methods in the end, because I'm not sure how that would have worked with the code that's there. But let's see, just to again try and satisfy my own curiosity, let's try this. So I can't value object there, which should be so props should be a B tree. So I should be able to do that. I'm not sure why it's not letting me new object. Oh, because it's yeah, I need to clone that. Okay, so it's still printing the stack trace, or not stack trace, the AST. So let's try again now. Print person age. And I'll do increase age, and then I'll do age again. The left hand side must be a variable. Okay, I will start off with just printing the person's age. Okay, we're off to a good start. At least that has resolved the first issue. The reason why it was an issue made sense. And I think that I have a generally better understanding on how to move forward next time. Okay, so in terms of the current work, let's go back to the Scratch file and just do a, oh, I did Control and S and hung the server for a second again. I do that too often. So current work is fix methods and add tests. So yeah, that will be the first order of business for the next day, and then I can move on to type methods and property access and things like that. Still a bit baffled by the fact that this possibly worked in the past in terms of the first or the previous iteration of this project. Now, whether I didn't copy the code correctly or there was something else going on, or I just didn't use the code, things like methods, as much as I thought I was, I'm not sure. But at least with all the tests that are there and the mechanisms for adding new tests, it should be straightforward to cover this new issue with a bunch of new tests and help with identifying it and preventing it from being reproduced in the future. So yeah, that's an interesting place to leave it anyway. I'll push the changes I have so far. So there was the work on underscores, and I think I already pushed the work on adding object destructuring collections. So that's that. Nice one. So yeah, interesting, I guess, tangent today, and still gave me a good amount of faith in the project and the new structure that's there and the new tests. In particular, I was very pleased with the fact that when I disable the rendering of the error wrapping, that it does give me the actual call history backtrace of the Rust side of the program, which I'm very happy with. So it worked basically as I expected there, and might be something that I add as a feature flag to the interpreter as well for helping with debugging in future. I'll see. I think it's kind of interesting and a useful piece to add on. But for the moment anyway, that's it for today. Went on a good bit longer than I was expecting, but like I said, had to satisfy my curiosity. So yeah, thanks to everyone who joined in and chatted, and see you again on the next time. Take care.